John, if you could go ahead and start the broadcast, and we'll get started. Again, my name is Jeff Mucci, RCR Wireless News. Today's presentation on how to manage QoS and QoE will be presented by Per Kangru from JDSU. I've got a couple of housekeeping items before we get started. The format today will be a presentation that will run 40 to 45 minutes, then we'll open it up for Q&A. The audience is encouraged to submit questions during the webinar, and as appropriate, we will respond to those questions either directly or in the presentation, but we do welcome questions throughout the presentation. So at this time, I'd like to introduce Per. Again, today's topic is content, value, and capacity, how to manage QoS and QoE. Per, thanks for joining us today.
Thank you very much, Jeff, and welcome everyone to this webinar. And today, as introduced by RCR and Jeff, we will look at a number of interesting topics and how these things together with our networks of today shape our challenges and our opportunities going forward. So, so with that, I would like to move on to the abstract and to look at what we're really going to cover here today. So, so overall, we have a set of new realities of today. I'm not going to talk about any of the hockey stick effects of the network going up, and I'm not going to talk about how many new handsets. I'm not going to talk about those type of things. But all of you know all of those things. But what I'm going to talk about is a little bit on what's behind this, what's behind the hockey stick, and what's included in that traffic model, and how does that impact the rest of the network, the rest of the quality of experience and the quality of service of the network, and how can you in an effective way take care of that and manage that situation. So we will look at both how the customer experience insight is gained. We will look at how you can use that information in an effective way to transform information and data going in from all of the data sources, and basically take actions on that, being it either in an operations environment or being it in a lab environment, and how you effectively can use all of that to create some sustained value across the ecosystem, independent on whether you are an equipment vendor or whether you're an operator inside this. And as Jeff said, any questions are appreciated, and we will do our absolutely best to cover them towards the end or separate follow-ups after the presentation. So JDSU, we are a global company. We are operating in a very large number of sites across the world. We have about 4,800 employees today, and we have an annual revenue of about 1.8 billion. And we consider ourselves to be leaders in the LTE test, and this has been recognized a number of times by a range of industry representation. And obviously, we are present in all parts of the world where LTE is rolled out and being engineered, being tested, being evaluated, being rolled out, being optimized, and being made operational. So from this experience, we are building a portfolio of solutions and a breadth of understanding, which we would like to contribute to the industry in various ways. These webinars is one of them. In other areas, we are involved in 3GPP standardizations. We are involved in IoT tests, etc. And this is always how we can contribute to the larger ecosystem and make sure that we further the opportunity for the whole industry to grow and manage these complex tasks. So let's first look at this gentleman here. So many of you either know this person, you have seen him, you have heard him, you have listened to him, or you have kids, or you may have relatives, etc., that definitely know him. But this is really an example of understanding what's behind the hockey stick, what's behind and driving the traffic explosion. So this is just one look at it. So in the first 100 days, this video of an artist called Sai It's a type of the music called K-pop. It really went viral. So in the first 100 days this was uploaded to YouTube, it generated more than 25 petabytes of traffic. So in 100 days, it generated more than 25 petabytes of traffic. And now, after about 140 days being on YouTube, it's generated more than 45 or 44 petabytes. So this represents that it's been viewed and downloaded more than 886 million times. This is obviously an enormous amount of traffic, and it's an enormous amount of traffic which has been flowing through all sorts of networks out there. Obviously, many of them are wireline networks, fixed line networks, which do not necessarily have any capacity limitation. But in certain cases, these are over mobile networks where this video is being downloaded, watched, it's consumed, and the question is, how have all of the mobile networks survived during this? And as a mobile operator or an equipment vendor supplying equipment towards mobile operators, what has been the impact to the end users' QoE and overall capacity management in the network of this single video? This is obviously just one example, and obviously on a daily basis, on a weekly basis, there are other exciting movies which is going viral and being downloaded and played all over the internet. So this is just one example, and one example generating this enormous amount of traffic. So the question is, what's going to happen, and are you ready for the next 25 petabytes? And do you have the means of understanding how you could optimize and manage this? Because there are techniques, there are ways to manage this, if it is on optimized content caching in the ROM, if it is on other things. And we will look a little bit on those type of things throughout the presentation here. The next question here is, which is really, what is this? And in this case, it is a game. It's a game that a lot of people played, became very popular, but that doesn't really matter, and that's not really the important aspect here. The important aspect in this case is that this is a financial driver for many, many entrepreneurs out there to try to get rich. Because the guys and the people who made this game and made it possible, they cashed out $180 million after about 8 weeks of going live with this game. So the key is these guys became filthy rich because they were able to drive a high revenue stream, a high amount of attention by a number of users in a very short period of time. So in 9 days, they grew from 0 users up to 1 million users. In the first 50 days, they grew to 50 million user base. This obviously generated a healthy amount of advertisement revenue, more than $100,000 per day, after about 6 weeks. But the critical thing which drives a lot of copycats, a lot of people who try to copy this, try to mimic it, build something similar or something slightly different to twist to it, get it out there, and try to capitalize on this. Many of those copycats, they will not be as good as the people who did draw something were on figuring out on how do I deliver this application over a mobile network without consuming a very significant amount of control plane resources. But a game like this, on the contrary to the video application of Psy, which consumed a lot of data, this application consumes a lot of control plane resources. Because downloading a advertisement, downloading a small command, uploading a small set of data, etc., doesn't consume a lot of data, but it utilizes enormous amount of control plane resources. And with now a number of people trying to replicate this commercial success, many of them will have no idea about ROM timers. They have no idea about how to tune them, what happens if you don't set them right, what happens if you don't manage it properly. And given that, there will be so many people that will write really bad applications, which will trigger the absolutely most awful state transitions on the ROM, and that will really have a big risk in causing a lot of congestion in the networks. So what I really want to say here is that we have drivers that drive a lot of traffic, and then we have drivers that drive a lot of control plane. Inside the ecosystem, there are a lot of people wanting to make money out of it. Not only network operators and the equipment vendors, but other people doing over-the-top services. They have the right motivation at this point in time, and that is something we, as in the industry, have to deal with and have to manage. And we will look at next steps on how could we take advantage of that. So, next question is, if you're now a mobile operator, you have a ability to go out there and launch a smartphone. And what happens if you now do this, but you are not doing it really right? What's going to be the media impact of that? And well, those of you who not try to Google something like an LTE smartphone and outage, well, you can do any sort of variations of this. When you've done that, you'll actually find that this delivers an outstanding number of results. In this case, about a week ago when I did this presentation, this generated 713,000 hits, and anyone can see that right now Verizon is on the top of this list, getting bad PR for all of the LTE outages they basically incurred in the early launches of the LTE smartphones. So the question is, how can you avoid this and how can you manage this? And we will look at as an example and a point. So the problem launching LTE and going into a network evolution is that in many cases you're driven by factors which is not necessarily always the technical ones. You're not necessarily driven by deadlines which are driven from an engineering department, but you're driven from a marketing department standpoint. But in this case, we had in North America, there was a really good LTE network. It was working perfectly fine. All of the quality of service and quality of experience was really good. And in this case, it was predominantly using USB dongles. And the USB dongle, the major characteristic of the USB dongle is that it's operating while your laptop is up and running. When the laptop is not up and running, your USB dongle probably sits in your bag and it's not used, which is for most people 95 to 99% of the time. That means that the USB dongle doesn't really stress the network for more than the period of time when it's used and actually active. And in majority of the cases, that means when the user is stationary, when it's in maybe a cafe, maybe majority of cases, those users are quite stationary. And stationary users using a USB dongle in this environment, actually it's pretty easy to get an LTE network working pretty well. And in this case, this operator had a really great network. It worked fantastically well. And all of the KPIs from a quality of service perspective was actually, really, really good. It was, really bright green. But then there was a decision to go out and launch a set of LTE smartphones. And literally over the weekend, all of these KPIs turned from bright green into bright red. And this was actually causing a lot of concerns and frustrations inside both the equipment vendors supplying the infrastructure and as well inside the operator. So in this case, they started to try to understand why do the KPIs really go this bad. And ultimately the answer was this is just what happens when you go from a fixed usage model into a very mobile usage model where the phone and the device is really operating 99% of the time rather than 1% of the time. So the devices which previously had been more or less sitting switched off for majority of the time were now instead sitting in the pocket, downloading emails, checking updates on various social networks, etc. And this was obviously happening in all sorts of mobile conditions, in all sorts of good or bad radio environments, etc. And this was obviously exercising a lot of different network behaviors that previously hadn't been very exercised. And this resulted in very significant decline in the quality of service. So from a technical point of view, how did the network operate? But as well from a quality of experience point of view, it became pretty much a nightmare. And anyone that lived through this exercise can obviously remember that soon there was a ton of social media discussing how you switch off LTE in these smartphones and instead move them into 3G and so on. So the question is, how can you be better prepared? How can you know what you're going to experience, and how can you be prepared for what's going to happen next? And once again, this is another topic we're going to cover now in the rest of the session. So, in the end of the day, these behaviors of either your users, either of your applications running on top of your network, which your users will use, what they will manage, how do you get the right visibility, and how do you drive for the right scalability and effectiveness in the data analytics, and how do you really get that turned down into a customer experience insight? So how can you really try to understand whether the general quality of experience in the network goes up or goes down when you start to see all of these viral applications or viral videos? Maybe the result is that the quality of experience is actually not degrading, although the quality of service might be degrading. So you might have indications that the network is starting to approach capacity limits, but at this point in time, it's actually not leading to a degradation in quality experience. So these are some of the critical things to understand, and then obviously going in and trying to do some of the what-if scenarios. So understanding, if I'm going to launch this smartphone, how does that impact my current environment? How do I move from a current environment into my new one without impacting my overall capacity, etc., in a detrimental way? So from JDSU's point of view, we really look at this holistically. We look at it from a way of how do we drive the right visibility. Visibility can mean many things. It can be data coming from the network equipment. Network equipment counters, network equipment KPIs. It could be trace records from the network equipment. It could be data from existing traditional probing systems. It could be software device clients, or it could be what we call the micro probes. So data could be coming from literally anywhere and everywhere. And being able to find out and take the right set of data at the right point in time, being able to pick it up from the right places across the network for the right use model, we see as quite essential. And then being able to drive that through a data analytics where you can be selective, but you can as well drive that through a DPI and data correlation engine, so you can actually start seeing some of the specifics of these type of viral applications. So you maybe have a marketing department who want to do a study from a day-to-day point of view and say, what happens to our network when this application, being it draw something or being it something else, goes viral? How does it spread? Who is the first people to pick it up, etc.? Make sure that this data can be used in the right way by the right departments so that you can drive the right visibility. That could be, as I said, from a marketing view, it could be from an operations point of view, or it could be obviously from a customer care department. So being able to understand whether certain users, for some particular reason, is impacted by in a very bad way from a network quality experience degradation. And if so, you might want to take specific actions to avoid that those users churn away. So this really means that we move from network traffic into actionable intelligence. But before we go into the rest of it here, I would like to hand over to Jeff for our first poll of the day. Jeff, if you would like to introduce that.
Thank you very much. I'm going to launch a quick poll. We'll leave it open for a minute and allow people to express their views on what is the main source of poor QoE today. So we'll leave this open for a few seconds and allow the audience to cast their vote. And we'll leave it up just a few more seconds while we get to about 70% of the audience casting their vote. By the way, Per, I like the 2 slides you have about the, I'm trying to imagine 25 petabytes of data and what really drives that.
Yes, that's an enormous amount of traffic, and just as a little bit of curiosity, this actually represents an average traffic of 29 gigabits per second since July 15th. So continuous 24/7, 29 gigabits of traffic generated and
Amazing.
Continuing.
Okay, I'm going to leave it open for 5 seconds. If you haven't cast your ballot on this quick poll, please do so now. Otherwise, we are going to wrap this up and continue on with the presentation. All right, I'm going to close the poll now and share the results with the audience. Per, do those results surprise you?
These are actually very relevant results, and as we can see, it's a tie between wrong capacity and poorly defined services in the mobile phones, and then there's a rather large quantity for backhaul, and this is absolutely in line with expectations, and I think we will see that the rest of the presentation actually touches upon exactly these types of topics. So this confirms that I think the rest of the presentation will be of strong value for the audience.
Okay, well, good. I'll hide the results now, and you can continue on.
Thank you very much, Jeff. So based upon this, we will really talk about how you can move it from the monitor data, being it the trends or the baselines or reports that you may have, and then really how you can take them and these reports and really turn them into statistical models of the user behavior, and how you can take those traffic models into a simulation environment. So this is being able to take a existing network. You can go out and take a golden cluster. This golden cluster you can then monitor. You will be able to see and understand that you have a set of user groups. You have a set of devices out there. You can see how the different devices behave, how many type of transactions they generate, etc. And based upon that, we are able to very quickly do a what-if analysis. So what happens if you, for example, substitute all of your current feature phones in the network with existing smartphones or new smartphones? And this is what we call a field-to-lab approach. So being able to take a field environment, bring it into lab environment, and in that lab environment, being able to basically drive the right type of simulation and drive the right type of analysis. Similarly, the question comes in, how would you be able to take a certain application and recreate that application behavior so that you can understand what happens if this specific application goes viral? This could be a native application that you develop in your own environment. So your marketing want to know what is going to happen to the network capacity if we launch this type of application. This application gets really interesting for the market, and we get a 20% uptake on it. What's going to happen to our network capacity? Are we actually going to consume all of the spare capacity we have today? and actually going to get a lot of congestion and blocking in the cell? Or are we actually going to be, I think, rather okay, and it would be a good idea to monetize our current assets? And this is as well a absolutely critical aspect of the whole scenario, or what we call the lab to field. And obviously, when you go from a field to lab, you go from lab to field, you can close a complete circle around here. So with that said, I'm going to look at one last scenario here, and some of you may actually have been in this environment and actually experienced this event. So some time ago in Japan, there was a commuter train which had a very, very minor accident, and that caused obviously a lot of concerns by the commuter around the delay. And as you know, in Japan, you're not using your cell phone to make a voice call when you're in a public transport, but instead you take up your phone and you start sending an IM. And this was using all sorts of IM clients and all sorts of phones. What really happened is that this caused an overload to the network, not necessarily of the data volume, but actually on the control plane loading side. So what really happened is that two of the most prominent networks in Japan went down for several hours. And part of the problem was obviously that the amount of control plane signaling triggered from all of these users triggered a overload in the existing 3G networks, and that caused the RNCs and other network elements to go down. The problem is obviously that the handsets and the applications, they were relatively aggressive in the retries. So as soon as the network came up again, all of the handsets and applications were immediately trying to resend these IMs, and well, it caused the network to basically immediately go down again. So the problem now was that in Japan and obviously in all sorts of countries across the world, there's been all sorts of testing done on the circuit switch side. So overloading on normal voice calls. Could it be for New Year's, or could it be for other type of special events when a lot of people want to communicate at the same time? And that type of priority management and so on has been tested and evaluated very closely. But when it comes to this, to the packet switch, this hadn't been evaluated very well, and it hadn't been tested very well. So in this scenario, our ability to very quickly recreate these type of signaling storms, being able to recreate the scenarios, allowed some of the vendor and some of the operators to very quickly recover from the situation, being able to put the right checks and balances in place so that once this would reoccur, you would be in a position to actually manage that without a network outage. Other alternatives could have been to try to initiate a dialogue with the Apples of the world and the Googles of the world who makes operating systems, or try to engage with the vendors of the different IM applications and try to get them to be, for example, less aggressive or try to manage the control plane load in a different way. The problem with engaging with the app vendors and the OS vendors is that what's popular today can really quickly change. So even if you engage with, say, 90% of the top vendors today, that is not likely to be the same 90% that's on the top in even 6 months from now. So it becomes it really doesn't become a successful strategy to go down that route. So we really see it's critical to be able to manage this natively and inherently in the networks, and being able to be ready for these situations and scenarios when they occur. So I've already spoken a lot about field to lab and lab to field, but it really turns out to be an ability to go 360 degrees around, being able to look at everything from the QoE and the QoS from a handset and device point of view out in a network, being able to take that data, take that information, bring it back into a lab environment, and specifically recreate that scenario, being able to say, how does this impact capacity in my network if this becomes popular? What happens if I introduce a small cell in my environment to offload capacity? Is that actually going to manage the situation well in certain scenarios? Being able to look at all of the what-if scenarios and do all of the network management and network planning, understand how both the network quality of service is taken care of, but then secondly, and maybe even more importantly, is how does the quality of experience impact, either improved or deteriorated by certain changes in the network or certain additions of being it could be anything from a 4G cell, a small cell, it could be a some Wi-Fi upload, or it could be something else. So these are all critical elements to drive the right type of visibility. And obviously, this stretches across all parts of the network and all parts of the activity, all type of technologies and all type of applications. So truly end-to-end. So with this said, let's now take a look at the live network. And let's take a look at a scenario where we had a set of highly valuable users. These were actually a set of business users, a small company doing some type of consultancy. They were generating a lot of revenue for the operator. They were early adopters in many areas, and actually one of them had signed up for a small cell service. But since he was working a lot, he actually had brought that small cell into the office, because almost everyone in the office had for quite some time complained about bad service. And he brought the small cell to the office, and well, as a result, basically, the quality substantially went up. The problem is that at one day, that small cell broke, and it wasn't functioning properly. This once again caused all of the users to be able to basically be forced to use a macro cell. These people's office were located next to the train station. So the problem was obviously that being at the train station, close to the train station, using the macro cell which was serving the train station, you are often in a very congested area with a lot of other users, and in general, this was, I mean, leading to very bad quality of experience. And obviously, through just the normal standard network monitoring tools and processes, it was clear that the small cell had been inactivated and was no longer working. But as it was not purchased as a business service, it was not rated as a high priority problem. And obviously, that was an impact which was, very significant from a quality of experience point of view, but from a quality of service point of view in the network, it wasn't rated very high. But by looking at the quality of experience of the different users in the network, it was actually very easy to pinpoint that these users were actually right now being significantly underserved, and they were actually at quite high risk of churning away. So by a proactive, senior customer care representative getting in contact with this user group, they were able to very quickly, understand the situation, and being very quickly to put in place a solution, obviously a new small cell, being able to use to offload their traffic, and obviously the quality of experience was basically taken back into very good quality experience. And this sounds obviously like a dream scenario, and very much like a made-up scenario. But I'm going to show you here in a couple of steps how this actually is possible to get to with the technologies and techniques we do have at our hands and our access today. So from being able to understand the profitable SOHOs, we can obviously find what the risk of churning away. So obviously, to be able to have a churn prediction, we obviously have a quality of experience engine going through any and all transactions that is made on the network, being able to calculate the quality experience of all of those transactions, relate them back to the subscribers, and from that way we can find certain groups and certain areas which have higher risk for churn. So in this case, that was very easily done. We were then able to go in and look at this specific user, and see where does he manage his majority of the transactions. And as most of you probably know, in a RON environment, majority of any transactions the user performs actually happens in a relatively small set of cells. So if those cells are actually having issues, it is very easy to understand which users will be most impacted. And in this case, we were looking at this user. We were able to see that they were using a cell which had a relatively low quality of experience rating. So in this case, the cell 5784, and we see a relatively high number of customer sessions on this cell. This was obviously the macro cell which they were on. From a network planning point of view and from a customer care point of view, this is a known cell to be relatively poor. The problem is obviously that with today's environment about getting new site permits, etc., it's not that easy to establish new sites and do cell splitting, etc., and cover that area with more capacity. And as well, the owner of the station building is actually asking for revenue share, so it would actually not necessarily be a profitable engagement to add more cells there. So in this case, we could identify the user. We could understand that he was likely to churn away. We could identify that he was on a macro cell which was overloaded, and he had a majority of the transactions there. And we can obviously see that from a customer quality rating that his worst experience is on the data side. So all of these things relate back to this type of users and how they basically have a lifestyle and an environment which both drives a lot of revenue for the operator, but as well is having certain expectations on the network. So with this said, we can then obviously in this case here we have the total list of all of the bad cells in the network. And yes, this is one of them which is on the top. And as you see, there is obviously 3 other cells which is even more worse, and those are, problematic for other reasons. But in this case, this problem stems from this specific one. So with all of this in mind, what we need to consider is how do we action this information? Because many of these problems and many of these areas and issues is not about whether you can or whether you cannot have the data, whether a quality of service system actually contained the information or not. The criticality is around, can you action it in your environment in a good way? And what we looked at here is one way of actioning on it, where we have a churn reduction department, which is specifically looking at how can we save certain high profitable customers, which is risking to churn away, and they have a good way of using this type of system for these type of proactive customer management. So if you look at from a customer experience tool, obviously going in and looking more detailed on a specific cell, this doesn't have to be this churn department's responsibility, but as well from an engineering department's responsibility. How can you go in and look at a specific cell, look at the specific quality experience, found in that area. If you look at a cluster of cells, how can you then drive up the quality of experience in this area? What happens if you introduce a small cell? What happens if you go in and add some specific remote radio heads? What happens when you drive some of these specific activities, which is going to add capacity? If you have the ability to very clearly move that into lab environment, drive a what-if analysis. And when I'm speaking about what-if analysis, I'm not talking about a computer-based simulation doing ray tracing or something. I'm talking about a actual model where you generate a number of users. It could be several hundreds, could be several thousand users, and drive their traffic through real base stations, through real clusters, and being able to validate the quality of experience of each and all of those sessions. So that type of what-if analysis, using this type of data as input data, we see as incredibly important. So looking at this from a separate step, we need to think about how do we go from a dashboard? How do we drive from the visibility of today? How do we look at what's happening? What's happening around us, in the world around us? Because ultimately, a network operator operates a network. That network is used by users to drive applications, drive voice services, drive data services, etc. But what they will drive, what they will use, will really change on a daily or weekly or monthly basis today. Of course, the operator can impact it by pricing plans, by specific ways to drive specific behavior, but really being able to take the reality of what's happening today, coupling it together with what's from a social perspective is happening out there, what is driving users today, being able to pinpoint that either from a very viral application, which is going around in certain subgroups of your users, being able to say, in this subgroup with only 10,000 or only 100,000 or even maybe only 1 million set of users using this application, it's not a big issue. But if all of my 50 million users or all of my 100 million users are actually going to pick up this application and start using it, what's going to happen to my network? Is it going to go down on its knees? Or maybe the opposite. How can I capitalize to make that happen? How can I create a specific service? How can I get my marketing department to get the real visibility to that service? It's now popular in these groups. We know from experience that once it's popular in a certain group, it's going to spread. It's going to spread in the next 3 months to the mainstream. Okay, can we now put together a package where we can make this very, very attractive and we can capitalize on it? This really gives you the right opportunity to go in and manage that, be on top of it, to capitalize on that growth. Or, if it's impossible for certain reasons to capitalize on it, being able to drive the right actions to manage it. So with that said, I'm going to go into a summary. And the summary is really from what we looked at. And it's really about how can we manage the unpredictable. Unpredictable, not as in unpredictable, it will never happen, or I could never imagine it to happen, but rather unpredictable from I don't know when it will happen, but these type of scenarios could happen. And how can I really manage that? How can I get on top of it? And how can I, in an environment as of today, where these changes change on a daily and weekly manner, how can I really get on top of this in a proactive manner to really make sure that you can manage the customer experience? Next step is obviously, can you monetize the quality of experience? Many of us have a lot of experience, being it from the days of GSM, being it of the days of cable and cable internet in the beginning, being in other areas. And all of us know from very hard-learned experience that ATM offered superior quality of experience, or sorry, quality of service management than Ethernet did. But today, the technologies being deployed is to a large extent Ethernet. Why? Well, the ATM quality of service management technologies were not interesting enough to pay a premium for. So the question now is, can we as an industry find out the right way to monetize quality of experience to our end users without overcomplicating it, without overcharging them, without making it too complicated for them to buy? How can we find that? How can we monetize it? We don't have the answer, but we know that we have the tools that can give you the visibility and the insight so you can get the answer. And that is really where we want to help. And the way we help is really that we drive this field to lab and lab to field strategy. Being able to monitor, manage visibility across the live network, being it from microprobes, being it from software agents, being it from handset agents, or being it from basically anywhere else. And this is really critical in the overall environment. So with this said, I would like to take the next poll here, just before we go to the Q&A. I would like to have the next poll. So please introduce that, Jeff.
Yeah. Thank you, Per. Everyone should see the second poll. What would be the most valuable investment to improve QoE in the network? We'll leave this open for 45 seconds to a minute. And as we did last time, we'll wait till about 70% of the attendees vote. And then we'll move into the Q&A. For those attending today's webinar, please submit your questions using the dashboard, and we'll spend about 10-15 minutes on a Q&A session here at the end. Okay, Per, the votes are coming in. We'll leave it open for another 5 seconds or so, and then I'll close it out. If you haven't cast your poll response, please do so now. We'll wrap it up in just one more. We still have a few people voting, Per, so I'll wait. Okay, good. So I'm going to close the poll now and share the results with the audience. Per, perhaps you could comment. Does this surprise you? What are you seeing in the market, and how does this compare?
So these answers are very interesting. So if you remember the first poll and the answers from that one, we had a tie between RON capacity and basically poorly devised and designed applications. So now we see here that majority of the people see that the ambient network probing with the CM monitoring, etc., is the most valuable item. And then obviously we see a test lab and test lab capability as number 2, but only as number 3, the increased RON capacity is basically highlighted. I think that this is a very this set of answers reflects that the audience of today must actually be very experienced in the field, because most people would normally throw capacity at the problem and say capacity is going to solve it. But here we have a very educated audience, which majority of them say, let's actually think about what we're doing, and let's put the right investment in place to make the overall network investment we have pay off in the best way. And I think this is a reflection of a very mature view in the industry. Of course, increased RON capacity is important, and it is one of the crucial things that will happen step by step and must happen. And in many networks, you will actually see up to a doubling of network capacity per year for maybe the next 10 years, which will lead to sort of 1,000-time increased RON capacity over the next 10 years. So RON capacity is definitely crucial, but to put it at the right place and make sure that that investment pays off in the right way, I think the audience here have captured very well in how to move ahead with. So that was very interesting and very positive to see. So with that said, I would like to open up for the Q&A.
Good. Well, one of the things that first comes to mind is it really important to consider quality of experience if you're already monitoring QoS today?
This is a good question, Jeff. So thanks for this one. So looking at quality of service, and this is really what we've been monitoring for years. So quality of service, if you have a great network operations center and you have a really skilled operations team, they can by themselves translate quality of service measurements into a quality experience impact of the users. The problem is obviously that this becomes more and more complex as you get a very diverse user base, very diverse expectations on a data service, a voice service, a overall connectivity, etc. So moving into quality experience system, it will allow your network operations team not to be experts in translating a quality of service degradation into a possible quality of experience degradation, but they can focus their energy on addressing it and fixing it, and basically, if necessary, take the right corrective actions. So really take your team and make them most productive in what really is going to drive your network performance and your revenue up. So it's a crucial transformation of really any operator or equipment vendor during these days. So thanks for that question. Let's go to the next one.
Okay, an audience question. How do you rate the QoE per user? What are the rates based on, and are these rates standardized?
So this is another great question. So with JDSU's, so in the Backend Touch CM solution, all of our ratings, they are standardized and they are out of the box to start with. So then we have compiled a set of KPI rules which are used to basically help the customer get started. So if it relates back to the first question, this is really what takes the quality of service and moves it into quality of experience, and basically allowing you to basically drive that insight. But obviously, you can then modify and customize these to really meet and drive the unique business interest of each operator. Because in each market, each operator obviously tries to differentiate themselves and basically drive their business model throughout the landscape. And we will allow them to very effectively drive that investment in the right way. And this means that when you can basically modify and customize these things, you can as well measure the KPIs on a per user transaction basis. Then via an algorithm, which you can as well define, you can calculate quality of experience for each of these transactions. And then you can aggregate these transactions for single customers to get the quality of experience for that customer, either over a complete lifetime of the customer or down to specific measured periods. And when you look at the questions about the standardization, and yes, the KPIs, they are quite common, but they are at this point in time not very well standardized. So that's an important aspect, that there's obviously a lot of work going on in the industry in that area, and we are obviously engaged in that in various ways. So thank you for that question, and let's move to the next question.
Okay, can you provide some examples when quality of experience was bad, even when measured QoS was good, and then vice versa?
This is a very interesting question. So can quality of experience be good when the quality of service is bad? And there's an old example which this question reminds me about, and I think all of you probably have had such a device. So most of you have had an old GSM phone, and when SMS was introduced, in many cases the SMS capacity, so the SMS gateway capacity was in many cases, substantially under-dimensioned. So that meant that in many cases you have the SMS. So SMS is now obviously built into the NOS procedure. So the phone had a SMS request to be sent when the SMS gateway was basically not available because it was over capacity. That procedure failed. So from a network point of view, the quality of service was shown to be bad. And now you had a couple of different behaviors between the different vendors. And in this case, there was two, let's call them Scandinavian handset manufacturers who actually had completely different ways of managing this. One of the vendors actually did not have any aggressive retry or trying to send the SMS. So it actually just basically put the SMS in the outbox and waited for the user to basically initiate a retry of that. So that led to from a measured point of view, a relatively okay quality of service, but it only had one failed transaction, where the other vendor actually had an aggressive retry, which retried to send the SMS every 10 seconds. And then after, I think, 10 retries, it went down to one each every minute, etc. But basically, from the same basically failed transaction, you instead had a very poor quality of service because you could have 50 or 100 failed SMS attempts. So if you only try to look from a quality of service perspective, you could very easily associate and say that this specific phone has very bad quality of service, whereas the other one has a much better one, because it only had one against, I mean, say 50 or 100 failed. But from an end-user quality of experience point of view, the phone that did a lot of retries actually gave a much, much better experience, because the SMS was sent. Sure, it wasn't sent immediately all the time, but it was sent in due time. And you got a response in due time, etc., etc. Whereas the phone which actually put it in the outbox, the quality of experience was really poor. So that's an old example which I think everyone can relate to, and it really shows that the quality of service may have very little to do with the specific quality of experience the user is getting out of the system. So thanks for that question and touching some old memories there. So let's move on to the next question. Thanks.
Okay, well, probably we've got time for one more question. So the last question is, what process should I follow if I want to implement a successful quality of experience process?
So I think we already have had a number of great questions, and the last one here I would say is not a great example of a very insightful question. So it's crucial that when you want to implement the quality of experience system, that you actually do that in a thought-through manner. Because just rushing ahead and deploying this without considering how you will use the data, from what parts of the network you will gather the data, and then how will you try to action in various departments this type of information. If just rush ahead, the risk is very high that a engineering department is just going to tune, so you once again just see the quality of service. So because you can obviously tune these algorithms so that doesn't represent quality of experience, but just represent quality of service. So by really thinking through what you want to get to, and really thinking through how you want to action this data, what changes are going to make in your processes to make this data efficient, then you can drive a very successful deployment with a very, very short ROI. So it was another excellent question. So thanks a lot, Jeff, and yeah, back to you.
Okay, I think we're at our time limit for today, Per. I thank you for your presentation. I thank the audience for attending today. Within the next few hours, the attendees will receive a link to the presentation, and the folks who did not attend but registered will also receive that link. Questions can be directed to Per. His address is shown on the screen. And at this time, we'll conclude today's webinar. Thank you very much, Per.